Okay, so here we're taking a look at actual texture. This is a piece by Meret Oppenheim. It's called Breakfast in Fur. It's from 1936, and it's a fur-covered cup, saucer, and spoon. So it's kind of a rude tactile experience, really. She presented it intentionally as kind of a contradictory object, designed to evoke strong responses ranging from revulsion to amusement. So the actual texture of fur is quite pleasant. It's fun to pet your cat or dog, right? But you actually don't really want that on your tongue or on your lips. So it's actually the idea of touching your tongue or lips to that is really kind of an unpleasant one. So she's kind of playing around with the medium, honestly, by putting fur over these objects that we would typically put in our mouth. So one thing that Native American art does is it uses texture and it combines a lot of textures into one object. So this is a man's bodice from the Northern Plains, 1835. So we have a variety of media here: buckskin, buffalo hide, deer fur, beads, and porcupine quills. So combining textures in one object is typical of the art of many traditional Native American cultures. So this is a man's bodice pictured here. The basic fabric is deer skin, painted in the upper part with the sleeves of buffalo hide. So there's some paint on here as well. And the round motif at the center is crafted from porcupine quills dyed in 3 colors in a non-representational design. It probably has some sort of symbolism behind it, but we're not quite sure what that is. Beads decorate the shoulder stripes and sleeves, and these varied textures make our experience of this object multisensory, so we can actually touch it with our fingers. Technically we probably couldn't because it's a museum piece, and we can also look at it with our eyes. Color. So we're moving on to color. Color is a component of light, and color can affect our thoughts, moods, actions, and even our health. Psychologists, artists, designers understand that colors can affect people on a very deep level. Artists often choose colors to help them express the emotion that they're trying to get across to the viewer. They use color to express moods, and there's a lot of different sayings, such as green with envy, red with anger, tickled pink. They're all common phrases used to describe different feelings and moods. The physics of color. Light is made up of wavelengths of light, and each wavelength is a particular color. The colors we see is a result of the wavelengths that are reflected back to our eyes. Objects appear different colors because they absorb some of the wavelengths and reflect other wavelengths back to our eye. White light is actually made of all of the colors in the electromagnetic spectrum, and so it contains all of the different wavelengths for all of the different colors. And white light from the sun, if it passes through a prism, it separates into bands of color that are made up of the visible spectrum. So you can actually see the different colors in white light if you run it through a prism. So let's take a look at that. Here's a prism, basically a kind of triangle of glass, clear glass typically. And if you put white light into one end of that, such as sunlight, the other end of it will actually separate all the different colors out of that white light, because white light contains all of the wavelengths. So red has a different wavelength than orange, and orange is different than yellow, and so forth, all through these all through the colors spectrum, basically. So each of the different wavelengths have, they have different lengths in between for each color, and they all pass through the prism at a different speed. So red has the longest wavelength, and it travels more rapidly through the glass than the blue, which has a shorter wavelength. Pigments and light. When light illuminates an object, some of the light is absorbed by the surface of the object and some is reflected. The color that appears to our eyes as that of the object, called the local color, is determined by the wavelengths of light being reflected by that object. So thus, if we see a red surface illuminated by white light, which is basically sunlight, it appears red because it reflects mostly the red light or the red wavelength and absorbs the rest of the spectrum. A green surface absorbs most of the spectrum except for green, which reflects light, which reflects the green wavelength back to our eye, and then so we see it as green. And that is the case with all of the hues. So this green can, we see it as green because the light comes at it, is absorbed, except for the green wavelengths, which actually reflect back into my eye. So I see that as green. When wavelengths of light are absorbed by a surface, if all of them are absorbed by the surface, then it appears black. If all of the wavelengths are reflected, it appears white. Black and white are actually not considered to be true colors, or their combination. Any kind of gray, black, or white are not true colors. They're achromatic, which means they don't have color, and they are referred to as neutrals. So black, white, and gray are not colors, they're neutrals. So hue refers to a particular wavelength of a spectral color to which we give a name. So colors of the spectrum, such as yellow, green, and blue, are all hues. So it's basically kind of like the name of the color is the hue. Just remember that, you'll be okay. Value refers to the relative lightness or darkness of a hue or color. So pure hues vary in value. So pure yellow is the lightest in value of all of the hues. Violet is considered to be the darkest hue in value. Red and green are middle value hues. Black and white are neutrals, and they are important ingredients in changing color values. So adding black to a hue, adding black to any color, creates a shade of that hue. So shades are created by adding black. When white is added, it creates a tint of that hue. So lavender is a tint of purple, and pink is a tint of red because they've added white to it. Intensity, also called saturation, refers to the purity of a hue or color. So a pure hue is the most intense form of a given color. It's the hue at its highest saturation in its brightest form. If white, black, or gray or another hue is added to a pure hue, its intensity will diminish and the color is therefore dulled. Pigment mixtures are called subtractive color mixtures. A lesser-known triad is the three light pigmentaries: red, orange, green, and blue-violet. So here we go. Here's a color wheel. The color wheel is used by artists to organize pigmented color. It's a visual diagram that makes it easier to see how one color might relate to another color. It is also helpful to artists who refer to the color wheel when trying to pick out a color scheme for an artwork. So it's organized in that it is organized by the primary colors, the secondary colors, and the intermediate colors, or the tertiary colors. So primary hues are always going to be red, blue, and yellow. So they're sort of at this triangle in the color scheme, and they're marked by ones in this particular color wheel. Secondary hues, we can see number 2 on the color wheel: orange, green, and violet. And you get secondary hues by mixing primary hues. So if we mix blue and red, we get violet. If we mix blue and green, or blue and yellow, we get green. If we mix blue or yellow and red, we get orange. So number 2 are the secondary color. Intermediate or tertiary hues are red, orange, yellow, green, blue, violet, and red, violet. The tertiary is located between the primary and the secondary, of which it is composed. So tertiary colors are created by mixing the primary and secondary colors. So blue with green creates blue-green. Yellow with green creates yellow-green, and yellow with orange creates yellow-orange. So that's what a tertiary or intermediate hue is. I like the word tertiary better than intermediate. So here we go, red, yellow, blue. Pigment mixtures are called subtracted color mixtures. So we also have, so this is the pigment primaries. And then there's also pigments of light. So the other one was more for paint, but we do have some that are made with the pigments of light. So that's called additive color mixture. This is like what your TV screen might use. And they have different primaries with additive color. So here's the additive color mixture. So we have red. So it's a little different. It's not red, blue, and yellow. It's actually red, green, and blue. And so one is basically with paint and one is with light. And there's such a thing as warm and cool colors. So warm colors are red, yellow, and orange. Cool colors are blue, green, and purple. And warm colors remind us of like fire and sun. And cool colors, such as blue, green, and purple, evoke a cool feeling because they remind us of like water and grass. And there's different color schemes. So here's another color wheel. So we can see the primaries, secondary colors. So secondary, I kind of like how they have this. So the primaries in the middle, secondary here. And then the tertiaries are the mixture of the primary and the secondary together throughout the color wheel. So the warm color versus the cool color. Warm, like I said, is red, yellow, orange, blue, and violet. Those kinds of colors are cool colors. Color schemes, so there's monochromatic, are based on variations of a single hue. So adding white or black to a single hue creates a monochromatic color scheme. Analogous are based on colors adjacent on the color wheel containing the same pure hue. So they're colors that are close to each other. So like if we look at the color wheel, it would be any of these colors that are close to each other would be analogous. This is also analogous. Anything over here, anything here. So anything that's close to each other is an analogous color scheme. Complementary are those hues that are directly opposite of each other. So this yellow and purple are complementary, red and green are complementary, and orange and blue are complementary color schemes. And there's other ones. I mean, whatever is directly opposite of each other are complementary color schemes. And they're actually commonly used in brand colors, actually. Branding for different products use complementary colors quite a bit. Moving on. Oh, here we go. Here's some color schemes. So this is the monochromatic color scheme, just all blue, but just different values. So different tints and shades created here from blue, all the same. So that's monochromatic. Analogous colors, so you can see they're all adjacent to each other in the color wheel. Usually pick 3 that are close to each other and call that a color scheme. Complementary, they're across from each other. So this piece by Keith Haring, it's called Untitled, Square Head with 3 Eyes, 1982, oil on canvas. This is used, he's actually using a complementary color scheme here. So red and green, and it's creating the complementary colors when you put them next to each other, create a very clashing effect, and it's actually kind of hard on your eyes. And I think he's experimenting with color in this piece. They're very intense and they really vibrate against each other. So that's why when you use a complementary color scheme, you have to be very aware that the colors really are very almost like clashing with each other and create a lot of vibration, and it's kind of uncomfortable to look at for very long unless you dull those colors down a little bit. So I mean, if he had used black or white to dull this color scheme down, that probably would have been helpful. But anyways, I will wrap up this lecture.